Alright, this video is going to be pin cap wiring on a Mark IV or 4A. The 4A receiver is the same board only. And we're just showing the locations and the wiring for the pin cap. This blue cap I have laying in there. I'm not sure if that's an original pin cap, but it might be a little bigger than the original, but that close. And I just stuck that in there to give you a location of the original pin cap in a 4A in the receiver. It's not marked. So the original cap goes from that back hole, and I replaced this big old clunky original, and it don't want to come out the hole. There it go. With this modern smaller one. And the original hole back here, that was the ground, and then I reused the positive on that side, and I drilled a small hole with a very small drill bit I got just for drilling holes that I can get leads through, and I made a new negative on this side. So the positive hole over here on the top side is reused, and I made a new negative hole, but originally that long cap there would go to the negative side. That's the original pin cap, but the original two UFs, they came because I think the FCC outlawed them having a ping noisemaker. You know, the FCC frowned on that, so they made them take the ping out. So they put in a smaller cap, a 2UF across there, and it's not marked. So if you want to put in a ping permanently, you can take out that 2UF that goes across there and put in a 20 for a short ping at 450 volt, 20 UF. 47 UF is popular for a medium ping, and 60 will give you a long, and over 60, like 100, to give you a very long, but that kind of stresses the radio a little bit. If you can fit one there, and to mount it there, it would be permanent. This 2UF here I put in because this is a customer's radio, and he wanted to be able to turn the ping off and on. So I got these two wires here coming out, and they go to a cover, a switch mounted to the cover on the back here. And that switch is small enough where I didn't have to drill a hole anything. Just got a small, I think it was a 3mm, or was it 5? I got bad memory. That fits through the hole, and it just mounted on the back of the chassis there. And then I put spade connectors, so when you take the cover off, you can disconnect the switch without having to solder anything or anything. You just disconnect the spade connectors so you can get the cover completely off. So when putting the cover on, all I got to do is plug in the spade connectors, and back in business. And then underneath, just wanted to show the wiring of how I did it, because I put in a second pin cap, because that original one that I put in on top is 2, and that's not enough to make it ping. I put in a medium 47 UF cap right here, 400 volt, and I put in the terminal strip here, I think. And also what I did is I drilled another hole right here to mount this red wire here on the board. Another very small hole, equivalent to a hole to get a pin through, or a component lead. And this is the 6AQ5 audio tube in the receiver here at the bottom. And the pinout for these I said I was going to use a pick or something instead of my finger. So let's try it. Alright, that's better. That's pin 1. It goes clockwise. Pin 2, 3, 4, 5, 6, and 7 on the bottom of that tube. And pin 6 goes directly to the pin cap. I actually think this terminal right here is where that pin cap originally mounts on pin 6, and then the other end would be up here to this ground joint up here. And under this blue wire is the additional joint that I made to mount the pin cap that I put in there. That small 2UF one. But the other one I put that you can turn off and on, I drilled this hole. Where am I? There I am. Up here in the terminal to mount the red wire there. And that red wire just goes across. And since that's positive, mind you, you got to keep electrolytic caps are directional. So positive has to be positive and negative has to be to negative, or else you're going to pop that cap. Sometimes they explode with a bang if you hook them up backwards. So that red coming from pin 6 goes to the positive terminal of this cap. And if you can see that gray with that little rectangular, that's negative side of that cap. And the negative, that wire comes around, goes up through that hole and out over here. Through my spade connector, it's going to go into the switch, and in the black, it's going to go directly to ground. So it goes out the switch into the black terminal here, through the hole, and any ground will do, but since this ground is close and it's right there, easy access, see how it's connected right to the chassis, I just put that black wire to that ground point right there, but any ground point would do for that. And that's all I did for that. And with that, we turn the switch on, we would get ping, we turn it off. We don't get ping. I already made videos of that, so I'm not even going to run that, but that's about all I wanted to go through. Oh, since I got this cap out, see this little indentation? Might be hard to see with the camera, but that indentation is going to indicate the positive side of the electrolytic cap. Also, if you see it, its backside is metal. Metal is going to be the ground side of the cap if it's not marked. And you can see this one is had heat problems and you can't see any markings on it. But indentation is always going to be a positive. That metal side there is always going to be the ground on this type of caps. And let me show one more thing. Let me pull up an electrolytic cap over here. Most caps are radial nowadays, which mean they're tall instead of long. Long is actual. But I just pulled a generic cap out, and even on a new cap, if you even can't see, you know, any markings or anything, the long lead is always going to be positive. Always. And the short lead, hence, is going to be negative. And if I turn it around here, you can see that gray thing again, indicating that that's the negative. But the long lead on these, on diodes or Anything else, the long is always positive on the leads. Just wanted to show that on new components. All right, that's it for this one. Next time, bye.